Hi everyone, today we're going to go over section 4.4. This does have two parts to it, so we're going to start with part A, and then after part A we will do part B. Alright, there is quite a bit of information in this section alone, so if we need to rewatch the video or pause, take our time, what have you, please do so. Get plenty of practice on this because it is taking us straight into what's called the unit circle, which will be the basis of trigonometry. All right, so please remember you can pause the video when you need to, or go back and rehear something if you miss it the first time. All right, so we're going to be talking about the trigonometric functions in a coordinate plane. So we're going to take our trig functions that we talked about last class, our cosine, sine, tangent, secant, cosecant, and cotangent, and now we're going to relate it to our normal x and y graph. Okay. The good news is it's going to be the same x and y graph. We're just going to rename it a little bit, but we'll talk about that. So to get started, we have these four pictures on the left-hand side. All right. I left all four on this piece of paper so that you guys can take a look and see. They all have the same initial side, I guess you could say. However, they're all triangles, but take a look at your theta. Remember, theta is the angle that's formed at the origin. That's the key word. It's always at the origin. So whether it's in the first quadrant, in the first picture here, your theta is coming off of the origin. In the second picture, our theta is coming off of the origin, but our triangle right here is getting used. Again, based off of the origin. Okay, it's not going to be a triangle that looks like this. All right, your right triangle always goes in line with the origin. Just as some rules as we go through these. Heading down, we have the third quadrant. I should be labeling these. The third quadrant, those are three eyes. And then the fourth one, of course, is the fourth quadrant, which is an I and a V represented together. So just some things to look at. We're talking about the angles off of the origin every single time. And of course, this was the second quadrant. All right. So some things to think about. As you look at these triangles, x and y represent the same x and y coordinate that we're used to, but then we also have an r. And lucky for us, r is going to be what's called the radius. R is the radius, if I can spell that correctly. Radius. And since r is representing basically your hypotenuse in every single situation, we always want to make note that it is always positive. Again, my x can be negative in some cases, depending on which quadrant we're talking about. Your y can also be negative in some situations, but your r, your radius, is always going to remain positive. All right. So taking a look, we'll just reference this first triangle here for all 6 of my trig functions. Remember your SOHCAHTOA rules. All right. So if I'm referencing that first triangle, cosine tells us to take your theta and you're going to do adjacent over hypotenuse. Well, this time my adjacent side is called x and my hypotenuse is called r. That's all we're going to do right now is label our information. Same thing for sine. We're going to do our opposite side over hypotenuse. So we get y over r. Tangent is opposite over adjacent. Secant is going to be the reverse of cosine. Remember, these go hand in hand, so it's now going to become r over x. Secant will become r over y. And last but not least, cotangent will be x divided by y. All right. Here's where things are going to change the most in all of trigonometry. We're used to seeing x's, we're used to seeing y's. Well, now we're going to understand how those get changed. All right? I am going to tell you that when we approach the next section of notes, our r, our radius, is always going to be 1. Okay, so when I talk about these right triangles now in the first, second, third, and fourth quadrants, my r is now 1. Let me write that over here, actually. When we talk about the unit circle, when I say unit, you should always think 1, just in any scenario, truly. Unit is 1. So now we can rewrite these really quickly. If I know that my r value is 1 in every single scenario, this is what's going to happen. Your denominator is going to be 1. So essentially, you're changing that entire function to say cosine of theta is now equal to just x. All right, and remember, I said we're doing some swaparoos. So now our x is no longer called x. We're going to call it our cosine theta. Every time you see cosine, we're going to remember that it relates to x. Similarly, whenever I see sine from here on out, I'm going to know that that's referring to my y. These are all of our trig functions. So we're going outside of x and y's, and we're going to now get into our trigs. So if I asked you for the coordinates x comma y, they're no longer going to be x and y's. They're going to be what's cosine of theta, comma, sine of theta. You're replacing every x with cosine and every y with sine. Now, do I expect you to have this down pat within seconds? No. But this is where we're going. Every time we see cosine, it is now, or excuse me, every time we see x, it is now cosine. Every time we see y, it is now sine. We don't want to see x's and y's any longer. So that's going to take me to tangent. All right. Well, if I'm talking trig functions, tangent of theta is y over x. But again, I don't want to see y's and x's any longer. I want to see sines, cosines, or tangents. So I'm going to replace that. I'm going to say tangent theta is now equal to sine theta, because that's my y, over cosine theta, because that's my x. So now we are going to understand that tangent is always sine over cosine. Every single time. It's still your opposite over adjacent, but now we're going to introduce sines and cosines and tangents. Okay? You can do the same thing with the next 3 trig functions. Secant of theta is the same as just 1 over cosine theta. Just to remind yourself that secant and cosecant go together. And your r is still remaining as 1. Cosecant theta is going to be 1 over sine theta. And cotangent theta is now cosine theta over sine theta. So all we've done so far is just renamed every single x in terms of y, and every single x in terms of cosine, and every single y in terms of sine. That is what's new for today. And we're going to go back to the basics one more time. In this next xy plane, all right, we have our first quadrant, second quadrant, third quadrant, and our fourth quadrant. Okay, nothing changes there. Now I want you to think back, okay, before we did this swaparoo. If I had both x's and y's in this first quadrant, I want to talk about positives and negatives. Well, in that first quadrant, my x is positive, my y was also positive. Well, we're not talking about x and y's any longer. We're talking about cosine, theta, and sine theta. Same rule applies. If your x was positive in that quadrant, your cosine is still going to be positive. And if your y was positive, your sine will still be positive. So we're going to go ahead and do all 4 quadrants now. All right. So same thing, I'm going to go back to the original. x comma y. Well, in the second quadrant, my x's are negative, but my y's are positive. So that tells me that when I have cosine theta and sine theta, my cosines are going to be negative and my sines will be positive. Third quadrant, x comma y. Both terms are going to be negative in that third quadrant. So when I get to my cosine and my sine, they will also be negative. And last but not least, my fourth quadrant, my cosine of theta and my sine of theta, cosine will be positive, sine will be negative. All right, now there's one last trig function that we haven't talked about, and that trig function is your tangents. So I'm going to go in one last time, and I'm going to label, well, what is tangent going to be in all four of these scenarios? And scroll up really quick. Remind yourself, well, tangent is always sine over cosine. So if I know if my sine is positive and my cosine is positive, then I'm going to end up with a positive value. So we're just doing sine divided by cosine based off of which one's positive, which one's negative. So in the first quadrant, I would have sine positive, cosine positive. Well, since they're both positive, then I know my tangent's going to be positive. Second quadrant, cosine's negative, sine is negative. Well, since one of them is negative already, and the other one is positive, that's going to make my tangent negative. Third quadrant, this time they're both negative, and a negative divided by a negative is going to give me a positive. And the fourth quadrant, a positive and a negative, so a negative divided by a positive will give me a negative. All right, notice how in the first and third quadrants, our tangents are going to stay positive, but in the second and fourth quadrants, my tangents will be negative. All right. This is the key right here. This little xy, which is now our cosine sine, this is our key to the remaining parts of these notes. All right, so I'm going to move down, but remember you have this as a reference on your first page if we need it. And we're going to just work through some problems based off of what's given. So our next few examples, we're going to find each of the 6 trigonometric functions of theta, the same 6 functions we talked about last time, our sine, cosine, tangent, cosecant, secant, and cotangent, okay? But we can't determine any of that information unless we have our triangle. So the triangle is going to be important. Remember which coordinates are negatives, which coordinates are positives, and we can go from there. All right, so let's get started on just question 1. We're given a point P, and that's at -3, -5. Those are still representing our normal x and y values that we're used to. And if I think about where that's going to get placed on my coordinates, that's going to be in the third quadrant. So let's make a triangle in the third quadrant. Again, make sure you're basing it off of that origin. So this is going to be my theta here. And we're always having a right triangle. Well, it says that this is the point right here. This would technically be my -3, -5. But I don't necessarily want to know that point exactly. I want to know my side lengths. Well, the side for this triangle is going to be -3 because that's representing my x axis. And then this side right here is going to represent my y-axis. So that's where I get the -5. Well, I'm missing one more side, so we need to revert back to our Pythagorean theorem, just like we did last class. And we say -3 squared plus -5 squared equals c squared. All right, now something's wrong with this function right now. If you use the calculator, make sure you're including parentheses on those sides. -3 and -5, when you square them, they should come out positive. So you get 9 plus 25, which is going to give me 34. Trying to get c by itself, so we square root both sides. 34 can only break down into 2 and 17. No lucky pairs there. So my hypotenuse is going to be the square root of 34. And remember, the hypotenuse always represents a positive version. So we're not going to worry about negatives there. That will be my positive square root of 34. And of course, this is my theta that I'm going to refer to when I do my 6 trig functions. So I have my right triangle. Now let's get into our sine theta, our cosine theta, and our tangent theta. I'll do the first 3 first. We'll worry about the reciprocals after. Same thing, SOHCAHTOA. So sine, opposite over hypotenuse. -5 over square root of 34. We don't like that as an option, so I'm going to convert it, multiply top and bottom by the root 34. We get -5 divided by the square root of 34. Sorry, -5 multiplied by the square root of 34 divided by 34. Cosine, adjacent over hypotenuse. Remember, if they have a negative associated with them, you are including that negative with it as well when you do adjacents and opposites. We don't like the root in the denominator, so our final answer should be -3 square root of 34 all over 34. And last but not least, our tangent is going to be opposite over adjacent. And of course, we remember that in the third quadrant, our tangent has to be positive. So we're going to just rewrite that as a positive 5 over 3. Okay. And as a quick reminder, you're in the third quadrant, so our cosine should be negative. Double check, cosine is negative. Our sine should also be negative. Double check, it's still negative. And our tangent should be positive. Okay. All just practicing and getting familiar with our sine being y's, cosines being x's, and tangents, memorizing which one's positive, which ones are negative. After the first 3, I can follow suit with the next 3. Cosecant theta, secant theta, and cotangent theta. Let's rewrite that there. All right, they're the reciprocals. So cosecant pairs with sine, so it's going to be a -root 34 over 5. Secant pairs with cosine, -root 34 over 3. If you want to put the negative on one of the tops or the bottoms, that's fine. I just put it out in front. That's just a me preference. And cotangent theta is going to be a positive 3 over 5. So nothing really new here. We're just practicing drawing the triangle first and then getting those 6 trig functions out of it. So we'll do the same thing on question 2. If you want to pause and try it on your own, by all means you may do so. And then you can come back and see what I have. So this next point, 1, -3, is going to be positive on our x, but negative on our y. So this is going to put us in the 4th quadrant. Let's say maybe right about here. I'm just making my triangles bigger so that I can make a bigger triangle in the end and just see a bigger picture. So this represents 1, -3. Well, that's going to give me the triangle here. I can build that in with theta being at the origin. My 1 represents my x and my -3 represents my y. So that's the lengths of those two sides. I don't know the length of the hypotenuse, so I'm going to use the Pythagorean theorem to help me out here. And I get 1 + 9 = c squared. That gives me a 10. Square root both sides, can't break anything down. So this hypotenuse is going to be the square root of 10. I got all 3 sides now, so I can figure out what my sine of theta is, my cosine of theta, my tangent of theta, and I can follow suit with the last three after this. Sine opposite over hypotenuse, -3 over root 10. Don't like that answer, so it's going to become -3 square root of 10 all over 10. Cosine of theta is going to be 1 over the square root of 10. Again, not a big fan of that answer because the radical is in the denominator. So I should get root 10 over 10. And last but not least, the tangent is -3 over 1. Make sure you're double checking and reminding yourself which ones need to be positives, which ones need to be negatives. So in the fourth quadrant, my cosine, your x, should still be positive. That's fine. Your sine, your y, should still be negative. And your tangent is also going to be negative. So all three are good as they are. I get cosecant theta next, as it pairs with my sine, followed by secant theta, followed again by cotangent theta. Cosecant theta, root 10 over -3. Secant theta, root 10 over 1. If you say just root 10, that will be fine as well. And cotangent is -1 over 3. Check and see how we did. You have my answers in front here, and we can go from there. All right, so with those first two done, we're gonna make it a little challenging after that. All right, this time, instead of being explicit with my values that I'm giving you, I'm gonna ask for just one trig function instead of all 6. You still have to make a triangle, but we have to basically put everything from page 1 together and think about it all at one time. All right, so let's go step by step. The first hint, the first clue says, suppose theta is in quadrant 3. Well, we know we're going to have a triangle in quadrant 3, so let's automatically make a triangle. Again, I'm just making a big one so I can look at it as such. Theta is in reference to my origin, and I know I'm working with the right triangle every time. And then it says that my sine theta in that same quadrant 3, that same triangle that we just made, your sine of theta would be -4 over 5. All right? Remember, your sine is always opposite over hypotenuse. All right? I'm going to worry about the negative in just a second. So I know that the opposite side of theta from the origin is going to be 4, and my hypotenuse has to be 5. So I'm going to take that fraction and I just applied it to my triangle. However, if I look at this triangle, take a look at your sine right now, your y value. Okay, it says 4, but it's not just 4, it's got to be a -4. That's where that negative from that fraction on sine has to go. Remember, your hypotenuse is never going to be negative. It's always positive. And based off of the picture, then my y value must be that -4. Well, it's asking me for secant. Okay, so in order to do secant, I have to know what my adjacent side is. Unfortunately, I don't have that, so I'm going to go back to my Pythagorean theorem. And I'm going to solve for that side that I'm missing. I get 16 plus b squared equals 25. And that gives me b squared equals 9. Take the square root. And this is where we have to be mindful. We're going to say, well, b has to equal 3. All right, let's put 3 in this section here for the missing side. 3 is getting represented as a positive value right now, though. All right, but if I know it's in that quadrant, then my x value has to be negative. That's going to be something we have to go in and make sure we include. All right, so make a note. We're going to say negative because, B/C stands for because. Negative because it's in the third quadrant. Okay, just be mindful of that as we solve our sides that are missing. We have to include the negatives as it will affect our answers. Okay. Then we have just the question, we'll find secant of theta. All right, so I don't have to find all 6 this time. I just have to find one of them. Well, secant I know pairs with 1 over cosine of theta. So in order to find secant, I have to know what my cosine of theta is first. So let's go in. And I know that secant of theta is going to be 1 over whatever my cosine is. So my cosine is adjacent over my hypotenuse, -3 over 5. This is where that reciprocal comes in. I'm just showing you that step. So I have a fraction over a fraction. I'm going to skip the top, flip the bottom, and multiply. That's where the reciprocal is going to help us. We're just verifying that this is indeed going to be the reciprocal version. And when I multiply, that's going to say our secant of theta equals 5 over -3. That's the only trig function they're asking for, so I can be on my merry way and keep going. All right, use the hints, start one hint at a time, and we can continue. Okay. Question 4 gives us 2 hints. We can't draw our triangle until we get through both hints and we understand them. All right. So first they tell us that tangent theta is equal to -2 over 3. Pay close attention. All we know so far is that tangent is negative in both the second quadrant and the fourth quadrant. So I'm going to make a note there. Quadrant 2 or quadrant 4. All right, I'll worry about the 2 and the 3 later, but I know the tangent is negative in the second quadrant or in the fourth quadrant. The second hint, however, is going to tell me where I need to place my triangle. And it says that my cosine of theta, formerly known as x, has to be greater than 0. Well, the only places x is greater than 0 is in the first quadrant or the fourth quadrant. So now that I know the 2 quadrants that they have matching, they both match in the fourth quadrant. So in order to follow both of these rules, my triangle has to be in the fourth quadrant. So that's where I'm going to draw it. And now I can go back to the information they just told me about the tangent. All right. They said tangent is -2 over 3. Well, tangent of theta, -2 over 3, that tells me that it's opposite over adjacent. So let's fill in those 2 values. We'll worry about the negative in just a moment. So my opposite is 2. My adjacent is 3. Looking at this picture, which one is going to have to get the negative? And that's going to have to be the 2. We just so happen to write it correctly the first time. Well, it's asking me this time for 2 trig functions. I need my cosine and I need my cosecant. This one's tricky. Cosine and cosecant do not pair together. Be mindful of that. All right. So I have 3 and -2. Pythagorean theorem. And that gives me 9 plus 4 equals c squared. Solve that. That gives us 13. Square root both sides. And of course, we're taking the positive version as that is my hypotenuse. And now I can solve my cosine theta and my cosecant theta. Let's put those together a little bit better there. All right. Cosine, we're going to do our adjacent over our hypotenuse. However, we don't like that completely, so it's going to now be 3 root 13 over 13. Cosecant of theta is the opposite version of our sine. So instead of doing opposite on top, I'm going to do the square root of 13, my hypotenuse, divided by my opposite, which will be -2. 2. And there you have it, our 2 trig functions for question 4. Go ahead and try question 5 on your own. You can pause the video, practice it, and then resume the video for where you want to check. Cosecant of theta is positive 1 over 3. Well, that only occurs in the first quadrant or the fourth quadrant. Cosecant of theta, remember that's your sine. It's just the reciprocal of sine, but it doesn't matter that it's cosecant or that it's the reciprocal. All right, but this time it's telling you that it's less than 0, so it needs to be negative. Well, sine is only negative in the third or the fourth quadrant. So it just so happens that our new triangle is going to be in the fourth quadrant again. Draw your triangle, label your theta. Go back to our cosine. Cosine is adjacent over hypotenuse. So my adjacent side is 1, Hypotenuse is going to be 3. I don't need to worry about any negatives on that one because cosine was positive to begin with, and it does match up with my sides. Pythagorean theorem, and that's going to give me 1 plus b squared equals 9. B squared is going to equal 8 this time, and if I square root both sides and I simplify that 8, I'm going to get 2 root 2. But this time, when I write in a 2 root 2, it's not just a positive 2 root 2, it is now a negative. Don't forget to check. And now I can find the 2 trig functions it wanted, cotangent theta and sine theta. Make sure you know your cotangents, your tangents, your sines, cosecants, and your cosines and secants. All right. Cotangent, well, if we think back to what tangent really is, tangent is opposite over adjacent, but this time I'm doing the reciprocal. So I want my adjacent side first over my opposite side, which is negative 2 root 2. Simplify that. You can either multiply by the entire denominator or just by root 2, whatever your heart desires, and you will get over 4. All right, remember, this actually should be a negative because that's in our fourth quadrant. Looks like I might have a typo on my teacher notes, but that should definitely be a negative root 2 over 4. Okay. For your sine of theta, we're going to do our opposite again, negative 2. Let me try that one more time. Negative 2 root 2 divided by our hypotenuse, which is 3. Always make sure you're checking which one's positives, which ones are negatives. You have all of that information on that front page of the notes. And that is all for section 4.4a. Okay. I will do 4.4b in a separate video, so please look out for that link. And then we will